In this video, we'll be showing 10 best structures that were detailed using Tekla Structures. Before we start, subscribe for more interesting videos. Let's get started. Number 1, we have the Burj Khalifa. This is the tallest building in the world, and its structural design was done by Schleich Bergermann Partners and Hilson Moraine. The project was completed in 2010, and it has 163 floors. The structural design of the tower involved the use of outrigger walls and a central concrete core to resist lateral loads such as wind. The facade of the building consists of a unitized system of glass and aluminum panels, supported by a structural steel frame. In Tekla, you can model complex structures like the Burj Khalifa by creating a 3D model of the building's structure, including the foundations, columns, beams, floor systems, and other structural elements. You can also model the intricate details of the building's facade and its supporting structure. This model can then be used to generate detailed shop drawings and other construction documents. Tekla's advanced visualization capabilities allow you to create realistic renderings of the building, which can be used for presentations and other communication with stakeholders. Next up at number 2 is the Shanghai Tower. This is the second tallest building in the world. It was completed in 2015. It has 128 floors and was designed by Gensler. The structure of the tower is a mega-column and mega-brace system, which is unique in that it uses a central concrete core and a series of strategically placed concrete columns and braces to resist lateral loads. The mega-column system allows for a more flexible and efficient structural solution compared to traditional outrigger wall systems used in other super-tall buildings. This approach enables larger floor plates and more efficient use of the building's internal space. In Tekla, you can model the mega-column and mega-brace system by creating a 3D model of the structural elements, including the central concrete core, mega-columns, and braces. You can also model the intricate details of the building's facade and its supporting structure. Number 3 on the list is the CCTV Headquarters in Beijing. This iconic structure was completed in 2012 and was designed by Rem Koolhaas. It has 2 main loops, a horizontal loop and a vertical loop, which are connected by a series of diagonal braces. This structure was created using Tekla Structures, which allowed the engineers to easily create and modify complex geometry. The software's ability to handle large amounts of data and complex models made it possible to design and visualize the entire structure, including all of its intricate details. The model created in Tekla Structures was used to generate shop drawings and other construction documents, ensuring that the building could be built accurately and efficiently. The software's advanced visualization capabilities also allowed the architects and engineers to create realistic renderings of the building, which were used for presentations and communication with clients and stakeholders. Overall, the use of Tekla Structures in the design and construction of the CCTV Headquarters resulted in an iconic structure that has become a symbol of Beijing. Moving on to number 4, we have the Guangzhou Opera House. This structure was completed in 2010 and was designed by Zaha Hadid Architects. It has a unique and eye-catching design that resembles a pair of giant scissors. The building's exterior is clad in white marble and granite panels that reflect and refract light, giving the building a shimmering appearance during the day and night. The interior of the Opera House is just as impressive, with a grand auditorium that can seat over 2,000 people, as well as smaller rehearsal spaces and studios. The building's design also includes sustainable features such as a green roof and rainwater harvesting systems. To create the complex geometry of the Opera House, Tekla Structures was used to generate a 3D model of the building's structure. This model was then used to create detailed shop drawings and other construction documents. Tekla's advanced visualization capabilities allowed the architects to create realistic renderings of the Opera House, which were used for presentations and communication with clients and stakeholders. Next up at number 5 is the Heydar Aliyev Centre in Baku, Azerbaijan. This cultural center was completed in 2012 and was designed by Zaha Hadid Architects. It has a unique and flowing design that has been compared to a liquid or a wave frozen in time. The building's exterior is clad in white glass and metal panels that reflect and distort the surrounding cityscape. Inside, the center features a concert hall, museum, library, and other public spaces. The Heydar Aliyev Centre was another project where Tekla Structures was used to create a 3D model of the building's complex geometry. The model was then used to generate detailed shop drawings and other construction documents. Tekla's advanced visualization capabilities allowed the architects to create realistic renderings of the center. which were used for presentations and communication with clients and stakeholders. At number 6, we have the London Aquatics Centre. This structure was built for the 2010 Summer Olympics and was designed by Zaha Hadid Architects. It has a unique and futuristic design that resembles a liquid form and was the first major project in the UK to be built using Building Information Modeling, or BIM principles. The London Aquatics Centre consists of 2 main swimming pools, a 10-lane competition pool and an 8-lane warm-up pool, as well as spectator seating and other facilities. The structure's design was heavily reliant on advanced technologies such as Tekla Structures, which allowed the architects and engineers to create complex curves and freeform shapes that would have been difficult to achieve using traditional drafting methods. Tekla Structures allowed for easy collaboration between different teams involved in the project, as the software could be used to create a shared 3D model that could be accessed by all parties. This allowed for better communication and coordination between the architect, engineers, and contractors. Moving on to number 7, we have the Beijing National Stadium, also known as the Bird's Nest. This structure was built for the 2008 Summer Olympics and was designed by Herzog de Morian Architects. It has a unique and distinctive design that resembles a bird's nest and was the largest sports stadium in the world. When it was built, the stadium consists of multiple rings that intersect and are supported by a steel frame. These rings are made up of smaller segments that can be opened and closed to allow for different configurations of the stadium. The Bird's Nest has hosted several major events since its construction, including the opening and closing ceremonies of the 2008 Summer Olympics, the 2015 IAAF World Championships, and several football matches. At number 8, we have the Shanghai Science and Technology Museum. This structure was completed in 2009 and was designed by Benoit. It has a unique and eye-catching design that resembles a sphere and a cube. The building's exterior is clad in glass and steel panels that reflect and distort the surrounding cityscape. Inside, the museum features interactive exhibits that showcase the latest scientific and technological advancements. One of the most striking features of the Shanghai Science and Technology Museum is its spherical IMAX dome, which is one of the largest in Asia. The dome provides visitors with an immersive experience when watching movies or live shows. Another unique feature of the museum is its central atrium, which is topped with a glass skylight that floods the space with natural light. The atrium houses a variety of interactive exhibits and is a popular spot for visitors to relax and take in the futuristic design of the building. Up next at number 9, we have the Tianjin Grand Theatre. This structure was completed in 2011 and was designed by Paul Andrew and Associates. It has a unique and catching design that resembles a broken chain and is considered one of the largest theaters in the world. The building's exterior is clad in glass and stainless steel panels that reflect and distort the surrounding cityscape. The theater features a grand auditorium with 2,400 seats, as well as smaller rehearsal spaces and studios. The Tianjin Grand Theatre is a cultural landmark in the city of Tianjin, in China. The theater has hosted numerous opera, ballet, and symphony performances, as well as serving as a venue for international conferences and exhibitions. And finally, at number 10, we have the Beijing National Convention Center. This structure was built for the 2009 Summer Universiade and was designed by Paul Andrew and Associates. It has a unique and eye-catching design that resembles a square and a circle. The building's exterior is clad in glass and steel panels that reflect and distort the surrounding cityscape. Inside, the convention center features a large exhibition hall, multiple conference rooms, and a grand ballroom. The Beijing National Convention Center is located in the heart of Beijing's business district and is a prominent landmark in the city. The convention center has hosted numerous conferences, exhibitions, and events, including the 2009 Summer Universiade and the BOH Forum for Asia Annual Conference. And that's all for now. Thank you for watching the top 10 structures detailed using Tekla Structures. If you enjoyed this video, don't forget to like and subscribe for more informative content. See you in the next video.